Hi class, this is our second set of notes in AP Chemistry. And the way that you are taking notes, again, it might be different on this one because it's images. If you are doing the PowerPoint notes, you're going to have 3 different pages. This is our second set of notes altogether, though. What we're really doing here is trying to identify the difference between physical and chemical changes visually, and also in terms of what types of attractions are changing, whether it's a chemical attraction, whether it's a chemical bond, or whether it is a physical bond or an intermolecular force. So we've got intermolecular forces and intramolecular forces. What's the difference? Okay, and we need to make sure that we understand that. All right, dry ice subliming is the first example. We're going from a solid state of matter, CO2, to a gaseous state of matter, CO2. Well, we can tell that we're going to increase the amount of randomness. These are going to spread out. The molecules will spread out. But we still have CO2. So we can say this is not a chemical change, it's a physical change, right? So when a physical change occurs, what I'm telling you is that intermolecular forces are all that changes. We don't have any intramolecular forces changing. Because I started with CO2, I still have CO2. So what's happening here is it was all clumped together like this as a solid. It changed to a gas, so it spread out. So the intermolecular forces also known as IMF. And you can use that abbreviation on the AP exam to save time. You can write IMF. I know what that means, okay? And so do the AP graders. Intermolecular forces, or IMF, are broken. Okay? They're being broken apart. That's why they're separating. They're able to separate because that attraction is not as strong. We got rid of or broke some intermolecular forces. All right, what about this one? This one kind of confuses people sometimes. We have something dissolving, like sugar dissolving. Well, it was sugar, and now it's sugar dissolved in water. Well, this is still a physical change. It's still sugar, it's just dissolved. So what's happening in this case is those sugar molecules that are clumped together in a solid formation, they're broken apart and they turn into this, they change into kind of a random orientation within the water. But they're also really attracted to the water molecules. That's why sugar dissolves so well in water. So what happens here is intermolecular forces, or IMFs, are broken, and new IMFs are formed. So we have some attraction between the water molecules and the sugar molecules. That's a new intermolecular forces. This actually does involve some hydrogen bonding. All right, moving on to the next one, propane gas burning. And you see this is a chemical change. But let's look at it and see kind of the evidence of that. Well, I start with C3H8. I have oxygen. I end up with CO2 and water. Okay, these are definitely different substances on both sides of the arrows, right? So we have evidence that a chemical change occurred. There's a lot of evidence that a chemical change occurred. So we started with propane and oxygen. We ended with carbon dioxide and water. What's happening here? Well, chemical bonds are broken, and new chemical bonds are formed. So there's definitely a difference between a physical and chemical reaction, and this is one of the ways it's different. You can see that the molecules we started with look different than the molecules we end with. They're rearranged, so you can visually see that they're different. Not only the state of matter changes, but their properties are totally different. And then also, we know that the chemical bonds are being broken and reformed, a different chemical bond being formed, not just intermolecular forces. Okay? And by the way, let's just write this over here. I think you know this already, but let's remind ourselves. Another word for chemical bond is intramolecular forces. We don't really use that a whole lot. We usually just use the word chemical bond because it's a little easier to distinguish. But I want you to be aware of that. So a chemical bond is an intramolecular force. It's a force that holds a molecule together. And intermolecular forces, which we abbreviate with IMF, those hold molecules close to each other. It's an attraction between molecules. An intramolecular force is an attraction or a bond within a given molecule or a formula unit if we're talking about ionic compounds. Now you've got some practice. We're going to go over this in the WebEx meeting. I want you guys to work through these two problems, answer the questions, and be ready to discuss that when we come back to class next time.